Hello everyone, I deleted the first stream because I lost my connection. I'm streaming over Wi-Fi and I have full signal strength. Excuse me, I have full signal strength, so I don't know what happened, but I just deleted that stream. Okay, so the reason I'm streaming right now is, and for those of you that do a lot of experimenting or know a lot about electricity, you may know exactly what's happening here, but to me, this is not making sense to me at all. At the moment, and that's okay. I don't need things to make sense to me. I just need to charge my batteries in the most efficient way possible. So that's what I'm thinking about. Not just in an efficient way, but a way that is helping me to think about electricity and electrons and charge in ways that are expansive for the imagination, if I say it that way. Anyway, so what I usually do here is I'm using the pulse width modulator motor controller, which is this is a 9 volt to 60 volt pulse width modulator, which they sell on Amazon for anywhere between $10 and $20. They have them that cost more as well, but this is just an inexpensive one. It's been working great for several years. So we have 84 volts going into this. Now that exceeds the voltage range for this. This is supposed to be 60 volts maximum. I just wanted to try it and see if it worked. I've been doing it, I haven't had any trouble, but I'm also not putting a lot of load on it. So maybe that's the reason it hasn't burned out yet. So we have 84 volts going into this, being maintained, that's the big battery there, being maintained by the battery charger up here, which was for the Viper scooter that I had at one time. I'm using this in place of a battery, and it allows me to control the speed, okay, how much power I'm sending to charging another set of batteries. If I recall correctly, this battery was 8 volts, and I think this one was at 5 volts. These are the voltage now. You can see now they're doing well. When I stop charging them, they're still at 13 volts approximately. But I want to get to 16 volts. When I charge batteries, I like to go up to 16 volts and then it comes back down. So that's what I go to, unless it gets hot. If it's getting hot, I'll stop. Okay, so here's the reason I'm streaming today is because I tried something different. I just wanted to try something. So here's what I'm thinking about. And hopefully you can hear me because I've got a lot of fans going in the background. My thoughts are, how can I charge these batteries? Right? How can I get the voltage up? Okay, so now I've been charging them now for 5 days. So what I usually do is I try to go up 1 volt each day. And I use my pulse width modulator. I turn it up a little bit each day. And the positive output will go through a motor. For example, it'll go through this motor. The positive will go in to the positive side, out of the negative side, and then go back, go to one of these. And the negative from the pulse width modulator can go directly to the negative. So the positive wire is running a motor in there, and then I put something like an alternator or another motor to help put a load on the motor, and that helps more amps to go in. Okay, now if you watch the first video, I was not able to use these larger motors on this battery when I first began. The voltage would go up, but there was no current. It was maybe like much less than 1 amp. So what I did was I tried the little motors here, these little motors, and I started with these, and it worked. I did that for a couple days, if I recall correctly, at least one day, and then it was putting some in there. It was putting some energy in there. Okay, now I don't know exactly what's taking place in there. I know a lot of people know a lot more than me about what's happening in there. What I'm going to say is it allowed the battery to start increasing voltage. That's all I can say. That's all I know that's happening. What actually is happening inside there, I don't know. But the voltage increased. And then once I did that for a day or two, I was able to use these larger motors and run the positive wire through one of these motors, which is using both wires on a motor, positive and negative, and having the positive wire go in, and then on the other wire, connecting that to the positive of the battery. Now, I was reading something about batteries being charged in series. As I understand it, the requirement to be able to do that because now we have 24 volts, right? If we put these in series, which they are, the voltage going into the pulse width modulator has to be greater than what this voltage is with these two batteries. So because we're at 84 volts, I can do that. Okay, so if I had the same voltage going into there, if I had 24 volts going into this, and these were in series, I don't think the charge would work. I've tried it before, and it just didn't, the motor wouldn't spin, and it wouldn't put any charge in there. Okay, so now getting to what the primary reason I'm streaming today is because I was trying to get my amps to go up more. That's just something I wanted to do in my test. And I thought, okay, I've already have a load on this. I mean, the load is spinning this alternator. The alternator itself does not have the field charged in there. So I'm not using the alternator to charge anything at the time. It's just slowing down this motor and allowing me to push more current, if I say it that way. I think I'm drawing more current in from the environment. I think that's what's actually happening into my batteries. So I thought, well, what if I one way of doing this is connecting this motor and another motor in parallel. And I'm not even sure that's what I've done, but I'm going to show you the way I wired this. Okay, so so one of these wires is just going back to itself here. As you can see, this wire is just going there. It's going back to itself. I'm not using it at the moment. But the other wire, we're going to follow. So the other wire coming out of the pulse width modulator, motor controller, this comes out, goes to this motor, right? Positive. This is my positive. Positive going into positive. And then on the positive, I ran this positive over to, this is now almost like I'm running these two motors like in parallel, right? That's what I'm going to call it, because that's a positive, and then I came over here to this positive, right? Okay, now even though we're only dealing with a negative wire, we're only dealing with a positive wire here. When we go in series, what does series mean? Series is positive, negative. The positive, I don't know how to say this, but somehow it's as if when we're in series, if we're just running the positive, I think that flips the charge on the other side. I'm not sure how to say that, but our wire goes in here, and then on the outside, okay, this is my negative, okay, which is still the same positive wire going through the motor, right? It goes into the motor, and then this is the negative. Now this negative, I sent it over to this negative. See what I did? Okay. So I have my positive going to this motor, positive, and I have the negative from this motor going over to this negative. And what was interesting is, a moment ago I had these motors wired in series in the same way. So I had one wire going into the positive, and the negative going to the positive, and the negative going to the positive, right? Now I'm wiring it where positive goes over to this positive, and then my negative wire, right, which I guess we're calling a virtual negative because there is no actual battery negative going to these motors. This negative going over to this negative, and then that going through the amp meter, which I'm getting over 2 amps now, which is great. That's what I wanted. I wanted more amperage, and I'm getting that. Look at the voltage on the batteries now. It's going up more than in the past, and these are barely working. See, they're barely spinning, and that's what I wanted, because the motors were working so hard that the motors were getting hot, and I didn't want that. I want these to work minimally. Minimum heat, minimum work, maximum battery charging, right? Yeah, that's what I want. Okay, that's what I'm thinking about, everyone. Okay, so we're at 2.2 amps. We're at 14.15 volts, 14.19 volts. Now these two batteries are in series. See this wire? They're here. And by the way, all these wires are staying cool. And the batteries too are very cool. I'm going to show you. Well, let's see what they're at now, because we are putting some current in there now. That's pretty cool, 71 degrees. Okay, so we're pretty good. 75 degrees. And it feels a little bit warm, but it's definitely not getting hot. And I'll watch that. Now, by the way, the negative of that output of the pulse width modulator motor controller, which is for brushed motors, these are brushed motors, they have brushes. And if you want to see what brushes look like, we'll show you right here. This is a good motor as an example to show you what brushes look like, because these things here are the brushes. They go into this, I think it's called a commutator, but they touch this thing. The brushes touch there and touch the center part, okay? So that's what brushes are. These are brushed motors, and that controller is for that kind of motor, brushed. Now, the negative output from that, because remember, we're running the positive wire through these two motors, right? And all that I explained to you here, which is a new thing I've tried, which is wonderful because it's giving me more amps into the battery. I'm gonna watch that. I want to get to 16 volts on these batteries. That's just what I'm thinking. That's my own thoughts. Okay, I'm going to 16. Do we need to go to 16? No. I think they're good now. I could just try using the batteries to see how they do. I will get them tested at the auto parts store. This is a very big battery, though. I think it's what is this battery? It's like a. Let's see if I could read it here. I don't know. I'm reading upside down, but if you could see that, it's very big. This is a very big battery, and this one's large too. Now, the negative from the pulse width modulator output is going directly to this battery. This is it right here. Okay, so let's follow it. That wire goes there. See it? Right there. That's it. Right there, on the top. The positive output goes into here, okay, and then goes over to this motor's positive, and then on the negative side, I'll call it a virtual negative, it goes to this negative, and then our same wire, right, that goes to our positive. Well, it goes to our amp meter first, 2 amps, and then goes to the battery, and the batteries are wired in series. So what we have from the pulse width modulator, negative wire goes directly over to this battery here, this negative pole. Positive wire goes into these two motors. These are acting as loads, okay? So it makes it harder for these to turn and helps my amps to go higher, which I want that because I want to put more amps in my batteries. That's just the present test right now. I mean, I don't think you need amps to charge batteries. Everything I'm learning right now is saying you don't. I'm reading a lot of material, and amps is just one way of, see, what is an amp? An amp's resistance. Do we need resistance? No, we don't need resistance. How does the universe work? Do you think the universe uses resistance to maintain the charge of subatomic particles? I don't know. Particle physics might tell us some theories on that. So Thomas Bearden talks about all particles are interacting with energy from the vacuum, which is just the energy in space, okay? Millions and millions of watts, and that's watt seconds, not watt hours. We talk about watt hours. Joules are watt seconds, right? Millions and millions of watt seconds available to us. All the power in the universe in every part of space. Right here, the space that my hand exists in, the space that surrounds my hands, okay? This is what powers all particles, right? This is theories. These are theories, but they're interesting. These two batteries are in series with this wire here. This wire is totally room temperature. Okay, so these batteries, like I was saying, I think this one was 8 volts 5 days ago, and 5 days ago this one was at 5 volts, if I recall correctly, and or vice versa, one way or the other. There was 5 and 8. I just don't recall which one is which. They're both up now, right now, to 14.2, 14.15. Charging these in series. So anyway, the main reason I made this video partly was because I wanted to show the way that I wired these two, okay? The idea is that the energy that is being used, I don't know if I'm going to say this correctly, but the best way to do it is to try to say it and just keep saying it until it makes more sense, or I find new words that are better, that are closer to the truth, right? Or I'm seeking truth right now. I'm seeking truth in the experiment. What's the truth of this experiment? What are the different truths that I can learn to see? So the energy that is moving these motors is not lost. If I understand correctly, all the energy, because I'm going through the positive wire, and I think you could do this with the negative wire as well. I don't think it has to be the positive. Can you do it with the positive and run loads through the negative too? What do you think? It's an experiment. You can try that. Sure, I'll try that someday. I've tried that already. Yeah, I don't recall what the details were, but I know I have probably a few hundred videos on it. I don't remember all my experiments. I'm just going step by step and looking for understanding. That's what I'm trying to do, is I'm trying to understand what's happening here. And how can I apply that to my scooters, right? See, here's a scooter right here. How can I apply this theory of what I'm learning to the micro-mobility transportation, right, of today? So, so the energy that is, one way of it that this is said is that the batteries are being charged at the rate of powering these loads, but the energy to power the loads is not lost to the loads, right? Yes, we have some warmth here, we have heat, we have friction. Not a lot though. Let's see where our temperatures are at. I mean, look at this. There's not a lot of heat there. If you've noticed, if you've been watching these videos, you'll see the temperatures of the motors have been going lower and lower as I find new ways to reduce the temperature by changing what I'm doing here and the way I'm wiring it, changing the way that I'm dispersing the load, if I say it that way. So, okay, look at where we're at. This one is at 78 degrees Fahrenheit, okay? And this one is at 68 degrees Fahrenheit, okay? That can be converted to Celsius on Google. So we have the fans here. This is the smaller motor, so I have the fans on it. This one doesn't have any fans on it. So the idea is that the energy is not lost to running these loads. So what do you want to do here, right? So what we'd like to do, what I'd like to do? Well, I want to charge this field, right? This is an alternator, electromagnet. I want to charge the field with a little bit of energy, a little bit. What if I put 1 volt in it at milliamps, right? 10 volts at milliamps. Or an amp at millivolts. Both ways. What comes out of here? And can I use that energy to charge these batteries as well, simultaneously, as I run these motors through the positive? Which is costing nothing to do that, right? That's the theory. This is the theory. That this motion has no cost because the energy from the environment permits this process. It's an efficient process, okay? So yeah, scooters, electric scooters, micromobility, all of micromobility and transportation, or anything that requires an electric motor, right? So we get to use our imagination. That's something we love doing. And this is a great opportunity to use imagination for what would you like to do within the positive wire. And the requirement is a difference in voltage from what I'm going to call the input, which this is the pulse width modulator, 84 volts in on this positive wire, and 12 volts that the positive wire is connecting to. So the energy is going to flow this way, right? Yes. Okay, everyone, it's been a great day. Thank you so much for being here. And I'll continue to share my thoughts and hopefully change the experiments and to continue to learn new things. Let's see. Yeah, we're at 14.2. So far going well. Okay, everyone, have a great day. Bye-bye.